In this video, we're going to derive the equation for electrical power. I don't need you to write anything, but it would be useful if you watched and listened. We already have some equations. This one is the definition for current. Current is equal to charge per unit time, also known as the rate of flow of charge. Potential difference is the energy per unit charge. And finally, from our previous module's work, we know that energy divided by time is equal to power. Let's start with these two equations. You'll notice that they have in common charge. So I'm going to rearrange these equations to make charge the subject. There we have it. Now if this is charge and this is charge, then that means that IT must be equal to E over PD, or the current times the time is equal to the energy divided by the potential difference, because here we have charge and here we have charge. There we have it. Now hopefully you can start to see the similarities between this one and this equation. We have energy and we have time. If we can rearrange it so that we have energy divided by time, then that will be equal to power. Let's rearrange that. First I'm going to multiply both sides by the potential difference. So I'll have I, T, PD, the current times the time times the potential difference. That will be equal to the energy. Then I'm going to divide both sides by the time, so that I end up with current times potential difference is equal to the energy divided by time, which is equal to the power. Don't worry if you didn't get any of that. The main idea is that you know that power is equal to current times potential difference. The unit of power is still the watts, the unit of current is amps, and the unit of potential difference is volts.